On a clear night, far from city lights, the sky does something remarkable. It stops being a ceiling and becomes a depth. The darkness opens outward, and scattered across it are points of light that feel both distant and strangely familiar. Among them is a shape that almost everyone recognizes, often without knowing why. 7 stars. A ladle. A dipper. A question mark turned sideways. You may have seen it as a child. You may have learned it from a parent, a teacher, or a book. You may not even remember when you first noticed it, but once you do, it never quite leaves you. No matter where you are in the northern hemisphere, no matter the season, that shape finds a way back into the sky. We call it the Big Dipper. But the Big Dipper is not a constellation. And the story behind it is far older, deeper, and more complex than most people realize. Tonight, we begin with something deceptively simple, a familiar pattern of stars. And slowly, carefully, we will uncover what it truly is, not just astronomically, but culturally, historically, and psychologically. Because Ursa Major is not just a group of stars. It is a mirror of how humans have always tried to understand the universe. To ancient eyes, the sky was not empty space. It was memory, it was direction, it was time itself written in light. Long before telescopes, before maps, before written language, humans looked upward and began connecting dots. Not because the stars were connected, but because the human mind is. The Big Dipper feels obvious. Its shape is clean, its stars are bright. They stand out against the background sky, but this sense of clarity is an illusion. What feels natural to us is the result of thousands of years of observation, repetition, and storytelling. We inherit this pattern the same way we inherit language, without questioning where it came from. Ursa Major, the Great Bear, is one of the oldest recognized star groupings in human history. Its story reaches back to the Ice Age, to a time when humans shared the land with massive animals, when survival depended on orientation, and when the night sky was a constant companion rather than a forgotten backdrop. This constellation has been named, reimagined, and reinterpreted by civilizations that never met, separated by oceans, continents, and millennia. And yet, again and again, they saw the same thing. A bear. Why did cultures with no contact share such similar interpretations of the same stars? Why did this pattern, above all others, endure? And why do we still see it so clearly today, even in an age of satellites and screens? To answer that, we must first let go of a common assumption, that constellations are natural features of the universe. They are not. The stars that form the Big Dipper are not close together in space. They are not part of a single object. They are not even the same age. Some are tens of light years away, others are over 100. The shape exists only from our point of view, from our position on Earth at this moment in cosmic time. And yet, it feels permanent. This is one of astronomy's quietest lessons. The sky is not what it seems. It is a projection, a shadow play, a map drawn from perspective rather than proximity. When we look up, we are not seeing objects arranged neatly on a dome. We are looking through layers of space, depth compressed into a flat image by distance. The Big Dipper survives this illusion better than most. Its stars are bright enough to cut through light pollution. Its shape is distinct enough to be remembered, and its motion through the sky is slow enough that it appears eternal within a human lifetime. But nothing in the universe is truly fixed. The stars of Ursa Major are moving, right now, every second. Over thousands of years, the shape subtly shifts. Over tens of thousands, it becomes unrecognizable. The pattern we know is temporary, a snapshot in a long cosmic dance. Ancient humans did not know this, but they knew something else. They knew that these stars never left. Unlike many constellations that rise and set with the seasons, the Big Dipper circles the North Star. Night after night, year after year, it rotates slowly around a fixed point in the sky. For people living in the Northern Hemisphere, it became a constant, a reliable presence in a changing world. This mattered more than we can easily imagine. In a world without compasses, without clocks, without maps, the sky was orientation itself. The Big Dipper pointed north. It marked time, it guided travel, it told stories that encoded survival knowledge. When people spoke of the sky, they were not being poetic, they were being practical. And yet, practicality alone does not explain why Ursa Major became a bear. A ladle, that is a modern invention. A plow, a wagon, those interpretations came later, shaped by agricultural societies. The bear came first. The bear mattered because it was powerful, because it was feared, because it was respected, because it was hunted, because it stood at the boundary between human and wild. For Ice Age cultures across Eurasia and North America, the bear was not just an animal. It was a symbol of endurance, strength, and cyclical rebirth, hibernating through winter and returning in spring. Seeing a bear in the stars was not arbitrary, it was meaningful. And this meaning was carried forward. As civilizations rose and fell, as languages evolved, as myths transformed, the Great Bear remained. The Greeks named it Ursa Major, the Romans adopted it, medieval astronomers mapped it, modern star charts preserved it. Even as science stripped the sky of gods and monsters, the bear endured. But what survived was not the bear itself, it was the pattern. And patterns are dangerous things. They feel objective, they feel obvious, but they reveal more about the observer than the observed. When we look at the Big Dipper, we are not just seeing stars, we are seeing the human tendency to impose order on chaos, to find meaning in randomness, to create stories from coincidence. This does not make the pattern false, it makes it human. Astronomy often feels like a science of cold distances and precise measurements, but its roots are deeply human. Before it was about light years and spectra, it was about recognition, about memory, about telling one star from another and remembering what it meant. Ursa Major sits at the crossroads of these worlds, myth and measurement, story and science. It is familiar enough to feel simple, yet complex enough to reward deeper understanding. And that is why it matters. Because when we truly understand the Big Dipper, we learn something not only about the stars, but about ourselves, about how we perceive reality, about how knowledge evolves, about how the universe can be both exactly what it appears to be and something entirely different at the same time. Clearing the confusion. The confusion begins with a name. When most people say the Big Dipper, they believe they are naming a constellation. The phrase feels official. It appears in books, classrooms, and casual conversation. It sounds like something fixed, defined, and astronomically precise. But in truth, the Big Dipper is something else entirely. It is not a constellation at all. To understand why this matters, we need to slow down and clarify a distinction that is rarely explained carefully, because it seems too obvious to question. But like many things in astronomy, the obvious answer hides a deeper truth. A constellation is not simply a group of stars that form a shape. In modern astronomy, a constellation is a formally defined region of the sky. It has boundaries, coordinates, and official recognition. These boundaries are not based on how stars look to the eye, but on precise divisions created to organize the celestial sphere. Every point in the sky belongs to one, and only one, constellation. This was not always the case. For most of human history, constellations were stories, not regions. They were shapes imagined by observers who connected bright stars into figures that made sense within their culture. These shapes often overlapped. Different cultures used the same stars for different stories. There were no borders, only patterns. That changed in the early 20th century when astronomers decided that the sky needed a standardized system. They divided it into 88 official constellations, each with fixed boundaries, much like countries on a map. These divisions were agreed upon internationally and remain in use today. Ursa Major is one of those 88 constellations. The Big Dipper is not. The Big Dipper is what astronomers call an asterism, a recognizable pattern of stars that forms part of a constellation but does not define it. An asterism is informal. It has no official borders. It exists because people notice it, remember it, and pass it on. Other famous asterisms exist: the Summer Triangle, Orion's Belt, the Teapot in Sagittarius. These patterns are useful, memorable, and visually striking, but they are not constellations in the technical sense. The Big Dipper belongs to Ursa Major, but it does not define it. This distinction seems minor, but it has consequences for how we understand the sky. Ursa Major is much larger than the Big Dipper. The constellation includes many stars that are rarely mentioned, rarely named, and rarely noticed. Some are faint, some form no obvious shape. They fade into the background unless you are looking for them deliberately. The Big Dipper, by contrast, dominates attention. Its 7 bright stars are easy to spot. Their arrangement feels intentional. Once learned, it becomes difficult not to see it. This is where perception takes over. When people look at Ursa Major, they often see only the Big Dipper and assume that is the whole constellation. The rest of the stars disappear from awareness. This is not a failure of observation. It is a feature of human cognition. We focus on patterns that are clear and ignore what does not fit them. In doing so, we unconsciously reshape the sky. The Great Bear of myth is far larger than the dipper-shaped outline we tend to imagine. The bear's body, legs, and tail extend beyond the familiar stars. Ancient star maps often depict a much more complex figure, one that requires imagination and cultural context to recognize. Modern observers rarely see this bear. Instead, we see a kitchen utensil. This shift tells us something important. Constellations are not static truths handed down by the universe. They are evolving interpretations shaped by culture, utility, and familiarity. The Big Dipper did not replace the Great Bear because it was more accurate. It replaced it because it was more useful. For navigation, the Dipper's bowl and handle point clearly toward the North Star. For teaching, its shape is easy to remember. For casual stargazing, it stands out even in imperfect conditions. Over time, practicality overshadowed mythology. And so the asterism eclipsed the constellation. This is not unusual in astronomy. Informal patterns often outlive formal ones in public consciousness. They survive because they serve a purpose. The Big Dipper is a tool as much as it is a symbol. But this dominance comes at a cost. When we collapse Ursa Major into the Big Dipper, we lose depth. We lose history. We lose the sense that this part of the sky has carried multiple meanings across thousands of years. We inherit a simplified version of a far richer story. The confusion also reflects a broader misunderstanding about how astronomical knowledge is constructed. Many people assume that constellations are objective features of the universe, natural groupings defined by proximity or physical connection. In reality, most constellations are visual coincidences. Their stars lie at vastly different distances from Earth. They are not gravitationally bound. They are not related in origin. Ursa Major itself is an exception in a limited sense. Some of its stars share a common motion through space, but even here, the constellation as a whole is not a single physical structure. The Big Dipper exaggerates this illusion. Because its stars appear so close together, the mind assumes they must be close in space. But appearances deceive. One star may be dozens of light years closer than another. Some are moving in slightly different directions. The shape holds only because of our viewpoint. Understanding the difference between Ursa Major and the Big Dipper forces us to confront this illusion directly. It reminds us that the sky is not arranged for our convenience. It only appears that way because we stand in a particular place at a particular time. If Earth orbited elsewhere, the Dipper shape would distort or vanish. If we lived thousands of years in the future, it would look different again. The Big Dipper is temporary. Ursa Major, as a region of the sky, will persist longer, but even it is defined by human agreement rather than cosmic necessity. This realization can feel destabilizing at first. It removes a sense of certainty, but it also opens a deeper appreciation. The sky becomes dynamic, interpretive, and alive with human history. When ancient people named Ursa Major, they were not cataloging stars. They were telling stories that helped them remember seasons, directions, and cycles. When modern astronomy drew borders around the constellation, it was not erasing those stories. It was organizing the sky for a new purpose. Both approaches coexist. The Big Dipper sits between them. It is ancient enough to feel timeless, practical enough to remain useful, and simple enough to survive cultural shifts. It is a bridge between myth and measurement. But it is not the whole bridge. As we move forward in this documentary, it is important to hold this distinction in mind. When we talk about Ursa Major, we are talking about a large, formally defined region of the sky with a long, layered history. When we talk about the Big Dipper, we are talking about a human pattern, one that reveals how perception, memory, and utility shape our understanding of the cosmos. Neither is wrong, but they are not the same. And once you see the difference, the sky never looks quite as simple again. Of human prehistory, the world was darker than anything we experience today. There were Ursa Major in prehistoric skies. Before there were names, before stories were written down, before the sky was divided into borders and coordinates, there were people who looked up and remembered. They did not know they were doing astronomy. They did not think of stars as distant suns. They did not separate the sky from daily life. For them, the night sky was not a subject, it was an environment. Tens of thousands of years ago, during the long span of human prehistory, the world was darker than anything we experience today. There were no cities glowing on the horizon, no electric light drowning out the stars. When night fell, it fell completely. The sky became a vast, luminous presence overhead, crowded with stars, stretching from horizon to horizon. In that darkness, patterns mattered. Humans are not passive observers of their surroundings. The brain is wired to seek order, to recognize repetition, to notice what returns again and again. In a prehistoric world filled with uncertainty, changing seasons, migrating animals, unpredictable weather, the sky offered something rare: consistency. The stars returned every night. The same shapes rose and fell. The same movements repeated, slowly and reliably. Among these patterns, some stood out more than others. Ursa Major was one of them. Its stars were bright enough to be seen clearly even through haze or thin cloud. Its shape was distinctive enough to be remembered, and most importantly, it behaved differently from much of the sky. It did not disappear for months at a time like many constellations. It did not sink below the horizon and vanish. It stayed. Night after night, it circled a fixed point in the sky, rotating slowly as the hours passed. To ancient observers, this made it feel anchored, tied to something stable and central. While other stars came and went with the seasons, Ursa Major endured. This persistence gave it significance long before it had a name. For early humans, memory was survival, remembering where animals migrated, remembering when cold would return, remembering where to travel and where not to. The sky became a memory aid, a canvas on which time itself was written. Ursa Major functioned as a kind of celestial landmark. It marked direction. It marked time. It marked continuity. And because it did so reliably, it became embedded in human awareness. We cannot know exactly how prehistoric humans thought about the stars. They left no written records, no diagrams of constellations, but archaeology offers clues. Cave art, carved figurines, and ritual objects suggest that early humans attributed meaning to animals, cycles, and celestial events. The bear, in particular, appears again and again. Across Ice Age cultures in Europe, Asia, and later North America, bears held a special place in human imagination. They were powerful, intelligent, and uncannily human-like in posture and behavior. They could walk upright. They hibernated and returned. They were both feared and revered. Some of the earliest ritual practices we know involve bears, bear skulls arranged carefully, bear bones treated with respect. These were not casual acts. They suggest symbolic thinking, storytelling, and belief. When early humans looked up and saw a persistent pattern of stars that seemed to circle the sky endlessly, it is not surprising that they associated it with the most enduring animal they knew. The bear did not vanish in winter. It returned. The stars did not vanish in winter. They returned. This parallel mattered. Ursa Major may have become a bear not because of its exact shape, but because of its behavior. It endured, it circled, it was always there. In a world defined by cycles of disappearance and return, this was powerful symbolism. The sky was not separate from the land, it mirrored it. For hunter-gatherer societies, orientation was everything. Knowing direction without landmarks could mean the difference between finding food and becoming lost. The stars provided orientation when the land could not. Ursa Major, with its steady rotation around the northern sky, became a natural guide. By watching its position, early humans could infer direction even in unfamiliar territory. They did not need to understand axial rotation or celestial poles. They only needed to notice what did not move. Over time, this practical knowledge blended with story. The pattern in the sky was no longer just a tool, it became a character, a presence, a watcher. And stories, once formed, are remarkably persistent. As humans migrated out of Africa and spread across Eurasia, they carried these sky memories with them. Groups separated by thousands of miles, living in vastly different environments, continued to recognize the same pattern. The stars were the same, the behavior was the same, the meaning evolved, but the core remained. This is one of the most remarkable aspects of Ursa Major's history. Unlike many constellations that differ wildly between cultures, the Great Bear appears again and again in places with no contact and no shared language. This suggests that the association is extremely ancient, older than most cultural divisions. Some researchers propose that the Bear constellation dates back more than 30,000 years, possibly originating with early Eurasian hunter-gatherers before populations spread and diverged. If true, Ursa Major may be one of humanity's oldest shared symbols. A story older than agriculture, older than writing, older than civilization itself. In prehistoric skies, there was no distinction between astronomy and mythology. The sky was alive with meaning, movements were watched carefully, changes were noted, unusual events, comets, eclipses, meteors were remembered and woven into collective memory. Ursa Major, by contrast, was reassuring. It did not surprise, it did not break pattern, it simply turned night after night, season after season. This reliability may be why it became foundational. Other constellations rose and set, appearing only at certain times of year. They were tied to seasonal activities, planting, hunting, migration. Ursa Major transcended season. It became a reference point against which other changes could be measured. In this sense, it was one of humanity's first clocks. Not a device, but a pattern, not precise to the minute, but accurate enough to notice change. Its position in the sky at dusk versus dawn, in summer versus winter, conveyed information. Over generations, this information accumulated. Prehistoric people did not measure time abstractly, they lived it. The sky reflected that lived experience. As millennia passed and human societies became more complex, these early sky memories did not vanish. They were absorbed into new cultures, new languages, new mythologies. The bear remained even as its story changed. When later civilizations began naming constellations formally, they were not inventing from nothing. They were inheriting fragments of a far older tradition, one that began when the sky was humanity's primary reference system. This is why Ursa Major feels different from many other constellations. It does not feel decorative. It feels foundational. Even today, when most people cannot name more than a handful of stars, the Big Dipper is instantly recognized. Children learn it early. Campers are shown how it points north. It becomes an entry point into the sky. This familiarity is not accidental. It is the result of tens of thousands of years of attention. We are still responding to the same visual cues that guided our ancestors: brightness, shape, motion, reliability. The human brain has not changed much in that time. We are still pattern seekers in a dark world. When you look at Ursa Major, you are not just seeing stars. You are participating in a lineage of observation that stretches back beyond memory. You are standing where countless others stood, looking up at the same slow rotation, the same enduring shape. The stars themselves have changed little in that time, but we have. We have given the pattern many names. We have told many stories. We have measured distances and motions our ancestors could not imagine. And yet the first response, the recognition, the sense that this shape matters, remains. The bear in the sky, origins of the Ursa Major myths. When the first stories were told about the sky, they were not entertainment. They were memory, they were instruction. They were a way of fixing meaning to patterns that otherwise drifted through the night, easy to forget and difficult to describe. A story turned stars into landmarks. A story made the sky usable. By the time written history begins, Ursa Major already carried a weight of meaning that felt ancient even then. Its identity as a bear was not new. It was inherited, passed forward through generations that had no record of when the association first began. This is important to understand. The bear in the sky was not invented by a single culture. It was remembered. Across Eurasia, long before Greek civilization rose, stories of a great bear already existed. These were not identical myths. They did not share characters or exact plots, but they shared a core image, a powerful animal bound to the northern sky, circling endlessly, never setting, never leaving. The consistency of this image is striking. In regions separated by thousands of kilometers, among people who never exchanged words or symbols, the same stars became the same creature. This suggests that the bear myth attached itself to Ursa Major very early, before cultures fragmented into the forms we recognize today. The reason lies partly in the stars themselves. The main stars of the Big Dipper form a shape that can be interpreted in many ways, but when additional stars of Ursa Major are included, the outline becomes more suggestive. With imagination, the body elongates, limbs extend, and the long tail, so strange for a real bear, takes shape. The tail, in particular, puzzled later observers, but early myth had no need to be anatomically precise. Myth is symbolic, not literal. The bear was not chosen because the stars perfectly traced its form. It was chosen because the bear meant something profound to early humans. In Ice Age environments, bears were among the largest and most formidable animals people encountered. They shared the landscape. They competed for food. They inspired both fear and admiration. Unlike many predators, bears could retreat from the world for months, then return. This cycle felt mysterious, almost supernatural. To early humans, hibernation looked like death followed by rebirth. The sky mirrored this cycle. Stars disappeared during the day, returned at night. Some vanished seasonally, others did not. Ursa Major, which never fully left the sky, embodied continuity. It endured through winter. It circled the heavens while the world below changed. This endurance mattered. For hunter-gatherers, survival depended on recognizing patterns that lasted. Animals migrated, weather shifted, but the sky was stable. Attaching powerful symbols to stable patterns helped anchor knowledge in memory. The bear became a guardian of the north. In many early traditions, north was associated with cold, darkness, and endurance. It was not a direction of abundance, it was a direction of challenge. The stars that ruled this direction naturally inherited qualities of strength and resilience. As human societies grew more complex, these early associations did not vanish, they evolved. By the time Greek civilization encountered Ursa Major, the constellation was already old. The Greeks did not invent the bear in the sky, they explained it. They wove it into their mythological framework, giving it names, genealogies, and narrative structure. This act of explanation was powerful. Greek mythology transformed inherited sky symbols into stories with characters, motives, and consequences. In doing so, it preserved them in written form. What had once been oral tradition became literature, and literature endures. The Greek story of Ursa Major centers on transformation, a human turned into a bear and placed among the stars. The specifics of the myth varied over time, but the theme remained consistent. A being caught between worlds, neither fully animal nor fully divine, bound to the sky as punishment, protection, or both. Transformation is a recurring theme in Greek myth, and for good reason. It reflects a worldview in which the boundary between human, animal, and cosmic is porous. The sky is not distant, it is connected. By placing the bear in the heavens, Greek mythology reinforced the idea that the stars were not inert objects. They were participants in the moral and emotional universe of humans. But even as Greek astronomers catalogued the stars more precisely, the myth did not disappear. Science and story coexisted. This coexistence is often misunderstood today. We tend to imagine a clean break between myth and science, as if one replaced the other. In reality, Science inherited the sky from myth. The names remained, the shapes remained, the stories lingered in language even as explanations changed. Ursa Major is a perfect example. Its name, Great Bear, is a direct translation from Greek. That name passed into Latin, then into modern languages. Even as astronomy became more mathematical, the bear remained in the sky maps. Why not rename it? Because names are anchors, they stabilize knowledge. Removing them would sever continuity with centuries of observation. Astronomers understood this intuitively. The myth was not a threat to science, it was a vessel. But the Greek version of the bear story was not the only one. Elsewhere in Europe, the stars of Ursa Major were seen as hunters chasing a bear. In some traditions, the handle of the Big Dipper became hunters or weapons. The long tail of the bear was explained as an injury, a wound inflicted during the chase. These stories attempted to resolve a visual problem. Bears do not have long tails. Rather than discard the bear, cultures adapted the story. The myth bent to fit observation. This flexibility allowed the core symbol to survive even when details conflicted with reality. This tells us something crucial about how myths work. They are not rigid. They are adaptive systems. As long as the central meaning remains intact, details can shift. The bear remained powerful. The sky remained a stage. The story evolved. In northern cultures, the bear often represented a sacred ancestor or spirit. In some traditions, speaking the bear's name was taboo. It was referred to indirectly, with euphemisms or symbolic language. Seeing the bear in the sky reinforced its elevated status. This reverence likely contributed to the constellation's persistence. Symbols that are respected are remembered. Symbols that are feared are repeated. Ursa Major benefited from both. As civilizations transitioned from hunting to agriculture, the bear's role in daily life diminished, but its symbolic power remained. The sky preserved what the land no longer required. Myths outlived their practical origins. By the time medieval astronomers studied Ursa Major, the bear was no longer a threat encountered in the wild for many people, but it was still a fixture in the heavens. Its story had become abstract, literary, and educational. This abstraction allowed it to survive cultural change. Even as religious worldviews shifted, the constellation names remained. Even as scientific explanations replaced mythological ones, the bear stayed where it was. Because the sky changes slowly, symbols attached to it gain inertia. Ursa Major's myth endured because it was tied to something that did not vanish within a human lifetime. Each generation saw the same stars. Each generation inherited the same names. The story felt timeless, even as the world below transformed. This is the quiet power of celestial myth. It does not demand belief, it persists through familiarity. Today, most people who recognize the Big Dipper do not consciously think of a bear. The ladle shape dominates modern imagination, and yet, the constellation's official name still carries the ancient animal. The myth is embedded in language, quietly surviving beneath modern interpretations. This layered history, prehistoric reverence, mythological explanation, scientific cataloging, coexists in Ursa Major. The constellation is a palimpsest, written and rewritten without ever being erased. Understanding the bear in the sky is not about choosing myth over science. It is about recognizing how deeply intertwined they are. The story of Ursa Major is not a relic, it is a record of how humans have always made sense of the cosmos. The bear was never just an animal. It was endurance. It was memory. It was continuity written in stars, Greek mythology, and the story that endured. By the time Greek civilization began to shape its understanding of the sky, Ursa Major was already ancient. The Greeks did not look up and invent the Great Bear from nothing. They inherited a pattern that had been watched, remembered, and named for countless generations before them. What they did exceptionally well, was give that pattern a story strong enough to endure written history. Greek mythology was not simply entertainment. It was a framework for organizing the world. It explained natural phenomena, human behavior, and the relationship between mortals and the cosmos. When the Greeks looked at the stars, they did not see distant objects governed by physics. They saw meaning written into the heavens. Ursa Major became part of that meaning. The most enduring Greek story attached to the constellation is one of transformation, power, and consequence. At its core is a mortal woman whose fate becomes inseparable from the sky itself. Over centuries, the details of the story shifted, but its structure remained intact. A human life altered, an injustice enacted, and a permanent mark left in the heavens. This permanence is important. Greek myths often end in motion. Heroes travel, gods intervene, monsters are slain, but the story of Ursa Major ends in stasis. The transformation is final. The sky becomes a prison and a monument at the same time. In the Greek telling, the woman at the center of the story is turned into a bear. The reasons vary depending on the source. In some versions, the transformation is punishment. In others, it is protection. But in all versions, the result is the same. She is removed from the human world and placed beyond it. This reflects a fundamental Greek idea about the cosmos. The sky was not simply above the earth. It was a separate realm, perfect, eternal, unchanging. To be placed among the stars was to be removed from time itself. Mortals who entered the heavens did not return. They became symbols. This is why the story mattered. By placing Ursa Major in the sky, the Greeks were not explaining where the constellation came from. They were explaining why it stays, why it never leaves, why it circles endlessly without rest. The story transformed a visual observation into a moral narrative. The bear does not set because she has been condemned or preserved to circle forever. The motion of the stars becomes a consequence of divine decision. Regularity becomes meaning. This way of thinking bridged the gap between observation and belief. Greek astronomers were keen observers of the sky. They tracked rising and setting stars. They noted seasonal changes. They understood cycles with impressive accuracy, but explanation did not stop at measurement. Observation invited story. The myth gave Ursa Major a reason to behave as it does. The long tail of the bear, so unrealistic anatomically, was explained not by discarding the bear, but by adjusting the narrative. Some versions describe the bear being flung into the sky by her tail, stretching it unnaturally. The physical inconsistency becomes evidence of divine action. This is not ignorance, it is mythic logic. Where modern science seeks internal consistency, myth seeks narrative consistency. The shape of the stars must serve the story, not the other way around. As long as the story explains the shape, the explanation is complete. And once written down, the story becomes durable. Greek texts were copied, studied, and preserved. Their sky myths traveled with them into Roman culture, into medieval Europe, into the foundations of modern astronomy. The name Ursa Major passed through centuries unchanged. Even when belief systems shifted, the language remained. This continuity is rare. Many ancient sky stories were lost, replaced, or forgotten as cultures rose and fell. Ursa Major survived because it occupied a central position in the sky and in navigation. Sailors relied on it, travelers referenced it, astronomers mapped it. Myth and utility reinforced one another. The Greek story also introduced a powerful idea that human lives could be written into the cosmos. This idea resonated deeply. It suggested that the universe was not indifferent, that the sky recorded history, that actions had consequences that echoed beyond the earth. In a world where most human lives left no lasting trace, the stars offered permanence. Ursa Major became a reminder that the sky remembers. As Greek astronomy evolved, myths did not vanish. Instead, they became labels, mnemonics that helped observers identify patterns. Students learned the stars through story. The narrative became a teaching tool. This practice continued into Roman times and beyond. Roman scholars adopted Greek constellations wholesale, translating names but preserving forms. The Great Bear remained the Great Bear. Its story remained intact, even as interpretations shifted. By the medieval period, the constellation had accumulated layers of meaning. It was at once a mythic figure, a navigational guide, and a scientific reference point. These layers did not compete, they coexisted. This coexistence challenges a modern assumption that science must replace myth to progress. In reality, science often builds on myth by stripping away explanation while preserving structure. The shape remains, the name remains, the story fades into the background but does not disappear. Even today, when astronomers speak of Ursa Major, they are using mythological language embedded in scientific practice. The bear walks quietly through star catalogs and coordinate systems, unnoticed but present. This persistence raises an important question. Why did this particular story endure while others faded? Part of the answer lies in position. Ursa Major dominates the northern sky. It is hard to ignore. Part lies in utility, it points north, but part lies in narrative strength. The story is simple, emotionally charged, and visually reinforced by the stars themselves. It does not require belief to be remembered. This is the mark of a successful myth. Greek mythology did not invent Ursa Major's significance, it formalized it. It took a prehistoric pattern and gave it a voice that could cross centuries. Without Greek texts, the bear in the sky might still exist, but its story might have fragmented beyond recognition. Instead, it became canon. But even as Greek myth solidified Ursa Major's identity, other cultures continued to tell different stories using the same stars. These stories did not vanish. They lived alongside the Greek one, especially outside the Mediterranean world. Many cultures, many stories. The stars do not change when cultures change. They shine the same way over deserts and forests, over oceans and ice, over civilizations that rise and fall without ever knowing one another. And yet, the stories people tell about those stars can be profoundly different. This contrast between cosmic consistency and human interpretation is nowhere clearer than in the history of Ursa Major. Long before astronomy attempted to standardize the sky, the Great Bear already belonged to many worlds. In Northern Europe, among early Indo-European cultures, the stars of Ursa Major were often seen not simply as a bear, but as part of a pursuit. The familiar shape of the Big Dipper became a moving scene, hunters chasing a great animal across the sky. The handle of the dipper transformed into spears or hunters themselves, while the bowl represented the bear's body. This interpretation did not erase the bear, it expanded it. The hunt was central to life. It determined survival, social structure, and ritual. Projecting the hunt onto the sky turned a dangerous activity into a cosmic drama, repeated night after night. The stars became a reminder of human struggle against nature, frozen into a pattern that could be revisited endlessly. In some versions of these stories, the hunt never ends. The bear is never caught. The chase continues eternally around the northern sky. This endless pursuit mirrors the stars' motion, always moving, never concluding. The sky becomes a reflection of effort without final victory. In parts of Siberia and Central Asia, the bear carried an even deeper significance. Among several indigenous cultures, the bear was regarded as an ancestor, a teacher, or a spirit being. The constellation was not merely symbolic, it was sacred. To speak of the bear casually was sometimes forbidden. Instead, indirect language was used. Euphemisms replaced names. The sky bear was treated with reverence, not ownership. Seeing Ursa Major overhead was not just observation, it was encounter. This reverence extended to ritual. Seasonal ceremonies aligned with the bear's behavior on Earth and in the sky. The constellation's position marked times of significance. Its endurance symbolized continuity between the living, the dead, and the unseen. Across Asia, interpretations shifted again. In ancient China, the stars of the Big Dipper were not a bear at all. They were a governing instrument of the heavens, a celestial authority. The Dipper was associated with order, regulation, and cosmic balance. It was seen as a tool used by heaven to measure time, assign fate, and maintain harmony. The stars were not characters in a story, they were mechanisms in a system. This reflects a fundamentally different worldview, where Greek and Northern traditions emphasized narrative and transformation. Chinese astronomy emphasized structure and function. The sky was a bureaucracy, not a mythic stage. Yet even here, the Big Dipper held exceptional importance. It was associated with the emperor, with cosmic law, with the alignment between earth and heaven. Its motion was studied carefully. Its orientation mattered. Despite the difference in interpretation, the core recognition remained. These stars were special. In Japan, influenced by Chinese cosmology but shaped by local belief, the Big Dipper became associated with protection and longevity. It appeared in religious symbolism, temple architecture, and talismans. The constellation was invoked for guidance and blessing. Again, the stars themselves did not change. Their meaning did. Across the Middle East, ancient cultures recognized Ursa Major as a key feature of the northern sky. While specific myths varied, the constellation was often tied to guidance, stability, and endurance. In arid environments where landmarks were scarce, the sky's reliability became essential. Knowing which stars never set meant knowing where north was, always. In Africa, interpretations differed by region, but the stars were often linked to animals, tools, or social structures. In some traditions, the Big Dipper represented a gathering, people or objects arranged in a meaningful order. The sky mirrored society. In the Americas, among indigenous peoples of North America, Ursa Major took on some of its most vivid forms. Many Native American traditions saw the Big Dipper as a bear pursued by hunters. The stars of the handle became hunters or birds. The changing position of the constellation through the seasons mirrored the progression of the hunt. In autumn, the bear was wounded. In winter, it lay low. In spring, it rose again. These stories were not static myths, they were calendars. The sky told time through narrative. Children learned seasons not by dates, but by stories written in stars. The cosmos became a living clock, readable without instruments. What is striking across all these cultures is not the diversity of interpretation, but the consistency of attention. Ursa Major mattered everywhere it was visible. This tells us something fundamental about how humans interact with the sky. Not all stars inspire story, not all patterns endure. Some fade, some are forgotten. Ursa Major did not. Why? Part of the answer lies in its physical prominence. Its stars are bright, its shape is distinct, its motion is slow and reliable, but these features alone do not guarantee cultural importance. Many bright stars never became mythic centers. Ursa Major became central because it combined visibility with usefulness and symbolism. It helped people navigate. It helped people tell time. It reflected animals and activities essential to survival. It stayed in the sky when others vanished. And so it accumulated meaning. Each culture layered its values onto the same pattern. Hunters saw pursuit, farmers saw tools, philosophers saw order, priests saw authority. None of these interpretations were wrong, they were contextual. This is a crucial insight. Constellations are not universal truths. They are interfaces between the human mind and the cosmos. They reveal less about the stars themselves and more about the people who named them. Ursa Major is not a bear. It is many bears, many tools, many stories, a single pattern carrying multiple truths simultaneously. Modern astronomy tends to flatten this richness. It assigns a single name, a single outline, a single explanation. This is useful for science, but it obscures the constellation's deeper role in human history. The Great Bear is a record of human perception. It shows how different societies, facing different challenges, found meaning in the same sky. It demonstrates that the cosmos is not just observed, it is interpreted. Even today, when most people learn Ursa Major through textbooks or apps, these ancient layers still influence perception. The constellation feels familiar, important, anchored. That feeling is inherited, not accidental. We are responding to echoes. Understanding these many stories does not dilute the truth of Ursa Major. It enriches it. It reminds us that knowledge is cumulative, not exclusive. Myth and science are not enemies. They are stages of understanding, each adding depth. The Big Dipper as a compass. Long before compasses pointed north, before maps were drawn with grids and scales, direction was learned by watching the sky. For most of human history, the Earth offered few reliable markers. Forests changed, rivers shifted, snow erased tracks, landscapes could mislead, but above all of this movement was something that did not lie. The stars. Among them, one pattern quietly became the most important directional guide humanity ever used, not because it was the brightest, but because it was dependable. The Big Dipper. To understand why, we must return to a simple truth that ancient observers knew intuitively. The sky turns, but it turns around something. Every night the stars appear to move. They rise in the east, arc across the sky, and set in the west. But not all stars behave the same way. In the northern sky, some stars never rise or set at all. They circle endlessly around a central point, like hands on a slow cosmic clock. That central point is the North Celestial Pole. Today we associate it with the North Star Polaris, but Polaris itself is not the pole, it is merely very close to it, and its usefulness as a guide depends on another constellation entirely. Ursa Major. The Big Dipper acts as a signpost. Two stars at the edge of its bowl form what are known as the pointer stars. If you draw an imaginary line from the lower pointer star through the upper one and extend it outward, it leads directly to Polaris. This simple relationship changed everything. For travelers, hunters, traders, sailors, and nomads, knowing where north was meant knowing where you were. It meant being able to return home. It meant being able to travel at night. It meant survival. What makes this remarkable is how little technology it required. No instruments, no measurements, no calculations, just recognition. A child could be taught the pattern, a story could encode the instruction. Follow the bowl, find the star that doesn't move. This knowledge could be passed orally across generations without ever being written down. The Big Dipper became a compass because it did not demand precision. It demanded familiarity. And familiarity is one of the strongest forms of knowledge. In the Northern Hemisphere, Ursa Major never fully sets. It rotates around the pole throughout the night and across the seasons. This made it visible year-round, a rare quality among constellations. At different times of year, the Dipper appears upright, sideways, or upside down. To the untrained eye, this might seem confusing. To those who understood its motion, it was information. Its orientation told time. Its position told direction. Ancient travelers learned to read this movement intuitively. They did not think in terms of hours or degrees. They thought in terms of position and change. The sky was a living map. For sailors navigating open water, this mattered profoundly. Before the invention of the magnetic compass, long-distance sea travel depended almost entirely on celestial navigation. Landmarks vanished beyond the horizon. Currents could push ships off course. The stars provided the only stable reference. Ursa Major was especially valuable because it worked even when the North Star was hard to see. If Polaris was obscured by cloud or haze, the Big Dipper could still guide direction indirectly. Its bright stars cut through imperfect conditions. This made it more than a constellation. It became infrastructure. In medieval Europe, sailors learned star lore alongside seamanship. Knowing how to find north using the Big Dipper was considered essential knowledge. It was taught not as theory, but as practice. Look here. Follow that line. Trust what doesn't move. The same knowledge spread across continents. Nomadic cultures crossing vast plains used Ursa Major to maintain orientation at night. Hunters tracked migrations using stars as reference points. Traders moved between distant settlements guided by patterns overhead. Even armies relied on the sky. Marching at night reduced exposure and heat. Knowing direction without light was critical. The Big Dipper offered certainty in darkness. What is striking is how long this knowledge remained relevant. The magnetic compass did not become widespread until relatively late in human history. Even after its invention, it was not immediately trusted. Early compasses were unreliable, affected by local magnetic anomalies. The stars, by contrast, had proven themselves over millennia. They did not drift. They did not fail. They did not lie. Ursa Major's reliability built trust. This trust extended beyond navigation. The constellation became associated with guidance itself, not metaphorically at first, but literally. Over time, the practical meaning softened into symbolism. The Great Bear became a guardian of travelers. The Dipper became a guide through uncertainty. Language reflects this. Phrases about finding one's way often carry celestial undertones. The sky, once a physical guide, became a conceptual one. Even today, in a world saturated with GPS signals and digital maps, the Big Dipper still serves as an educational gateway to navigation. Campers, scouts, and outdoor instructors teach it as a foundational skill. not because it is the most efficient method, but because it connects people to something older. Learning to find north using the stars creates a sense of continuity. It reminds us that orientation is not only about coordinates, it is about relationship. You learn where you are by learning how you relate to the sky. This is something modern navigation tools obscure. When a device tells you where you are, you do not need to understand your surroundings. When the stars guide you, understanding is required. You must observe, you must remember, you must interpret. Ursa Major demands participation. There is also an emotional dimension to this guidance. Knowing that the same stars once guided ancestors across unknown landscapes creates a quiet sense of connection. The act of following the Big Dipper is not just functional, it is historical. You are repeating an ancient gesture. The Big Dipper's role as a compass also influenced how it was depicted culturally. In some traditions, its stars were imagined as tools, ladles, plows, wagons, not because these shapes were obvious, but because tools are instruments of guidance and work. They make order possible. The sky was doing work. As astronomy developed into a formal science, the practical importance of Ursa Major did not diminish immediately. Early astronomers still relied on naked-eye observation. Star catalogues were organized with reference to familiar patterns. The Great Bear remained a fixed point in celestial mapping. Only in the modern era did its navigational role become optional rather than essential. But optional does not mean obsolete. There is something deeply grounding about using the stars to orient yourself. It bypasses abstraction. It anchors you physically in space and time. You are not just somewhere, you are here, under this sky, facing this direction. Ursa Major offers that anchor. Its function as a compass reveals a deeper truth about constellations in general. They were not created for aesthetics, they were created for use. Beauty came later, layered atop function. The Big Dipper's enduring prominence is not accidental. It earned its place through reliability. It became meaningful because it worked. In a universe defined by motion and change, the stars that guide us become symbols of stability. They feel trustworthy because they behave predictably across human lifetimes. This trust is emotional as much as practical. Even today, seeing the Big Dipper can evoke a sense of reassurance. It is familiar, it is steady, it points somewhere definite in an otherwise ambiguous sky. That feeling has roots older than civilization. What are we actually seeing? When you look at the Big Dipper, it feels like a single object, a shape, a thing. 7 stars arranged just so, bright enough to cut through darkness, familiar enough to feel almost close. But this sense of closeness is an illusion, one of the most persistent illusions in astronomy. Because the stars of the Big Dipper are not neighbors. They are not clustered together in space. They are not bound by gravity. They are not even the same age. What unites them is not physical connection, but perspective. From Earth, these stars line up in a way that appears meaningful. From almost anywhere else in the galaxy, the pattern would dissolve. The Dipper exists because we stand here at this moment, looking in this direction. This is one of the first quiet shocks astronomy delivers. The sky is a projection. The stars that make up the Big Dipper are scattered across a vast three-dimensional volume of space. Some are relatively nearby, others are much farther away. Light from each travels a different distance to reach your eyes, meaning you are seeing each star at a different moment in its past. When you look at the Big Dipper, you are not seeing a single time. You are seeing a layered history. Some of those stars may have brightened or dimmed slightly since the light you see left them. Some may have changed in ways we cannot yet detect. The shape feels frozen, but the reality behind it is dynamic. To understand this, we need to slow down and meet the stars individually, not as points in a pattern, but as physical objects. The stars of the Big Dipper vary widely in size, temperature, and brightness. Some are massive, hot stars that burn their fuel quickly and live fast, short lives. Others are more stable, longer-lived stars closer in mass to our Sun. They do not share a single origin. This surprises many people. There is a natural tendency to assume that stars forming a recognizable pattern must have formed together, like siblings. In most constellations, this is not the case, and the Big Dipper is no exception. However, there is a subtle twist. While the stars are not bound into a single cluster today, several of them share a common motion through space. This motion suggests that they may have formed long ago from the same cloud of gas and dust, before drifting apart over hundreds of millions of years. This shared motion is not obvious to the naked eye. It reveals itself only through careful measurement, through tracking how stars shift their positions relative to more distant background stars over time. This phenomenon is called proper motion. To human eyes, stars seem fixed. Over a lifetime, their positions appear unchanged. But in reality, every star is moving, sometimes at extraordinary speeds, around the center of the galaxy. The Big Dipper is a rare case where this motion is coherent enough to be detected as a group. Several of its stars are traveling in roughly the same direction, like debris from a long-dispersed family. This does not make the Big Dipper a true star cluster, but it does hint at a shared past. That past, however, is unimaginably distant. The stars we see today may have formed together hundreds of millions of years ago. Since then, they have drifted across the galaxy, pulled by gravity, influenced by galactic rotation, passing other stars silently in the dark. The Dipper shape is a temporary alignment, a coincidence sustained by the slow pace of cosmic change. Now consider distance. The nearest stars in the Big Dipper are relatively close by astronomical standards, while others are more than twice as far away. This difference is enough to shatter the idea that the pattern exists as a flat object in space. If you could step far outside the solar system and look back at these stars from a different angle, the familiar ladle would stretch and distort. The handle would bend, the bowl would unravel, the Big Dipper would vanish. What remains would be 7 unrelated stars, scattered across depth. This realization forces a change in how we think about constellations. They are not things the universe built. They are things the human mind assembles. But this does not make them meaningless. On the contrary, it reveals something profound about perception. Humans evolved to interpret flat projections, shadows, silhouettes, outlines. The sky is the largest shadow play we ever encountered, and our brains respond to it instinctively. The Big Dipper persists because it aligns well with how we see. Brightness plays a key role here. The stars of the Big Dipper are among the brightest stars visible from Earth. Brightness is not just a function of size. It depends on distance, intrinsic luminosity, and orientation. Some stars appear bright because they are large and hot. Others appear bright because they are relatively close. The Big Dipper benefits from a fortunate combination of both. Its brightest stars are easily visible even from suburban skis. This has helped preserve the pattern in an era of light pollution. While many constellations fade into invisibility near cities, the Big Dipper often survives. This survival reinforces familiarity. Children learn it early. Beginners in astronomy use it as a starting point. Apps and star charts highlight it prominently. Over time, the pattern becomes a mental anchor, a reference from which the rest of the sky is explored. But familiarity can hide complexity. Each of these stars is a sun, burning nuclear fuel deep in its core. Each emits enormous energy, radiating light across space for decades, centuries, or millennia before it reaches Earth. The photons entering your eyes tonight began their journey long before modern civilization existed. This is easy to forget when stars are treated as dots in a diagram. Astronomy constantly asks us to hold two truths at once. The stars are unimaginably distant and intimately present. They are physically unrelated and visually unified. They are ancient and changing right now. The Big Dipper embodies all of these contradictions. There is also an emotional response tied to this knowledge. When people learn that constellations are illusions, some feel disappointment, as if something familiar has been taken away, but others feel the opposite. The sky becomes deeper, richer, more layered. What once seemed simple now carries hidden dimension. The pattern does not disappear, it gains context. Knowing that the Big Dipper is not a physical object does not make it less real. It makes it more human. It exists because of how we see, how we remember, and how we share experience. And yet, science does not stop at demystification. It replaces myth with wonder of a different kind. Understanding stellar life cycles, how stars are born, age, and die, adds drama to the sky that no myth can match. Some of the stars in Ursa Major will burn out long before others. Some may end their lives quietly. Others may shed outer layers or collapse. Over cosmic time, the pattern will not survive. The Big Dipper is temporary. This fact reframes everything we've discussed so far. The ancient bear, the hunter's chase, the compass in the sky, these were all built on a momentary arrangement in a universe defined by motion. And yet, that moment is long enough to encompass all of human history. We exist in a narrow window of cosmic time where this pattern is visible, recognizable, and useful. Our myths, maps, and memories grew within that window. Future observers, if they exist, may see a very different sky. They may not recognize the Big Dipper at all. This does not diminish its importance. It enhances it. It turns Ursa Major into a reminder that meaning arises not from permanence, but from relationship. We assign meaning to what is stable enough to matter. Motion in the sky, Ursa Major is not fixed. The night sky gives an impression of stillness. Stars appear nailed in place, locked into patterns that seem eternal. Generation after generation looks up and sees the same shapes, the same arrangements, the same familiar groupings. This apparent stability invites a powerful assumption that the sky does not change. But it does. It changes constantly. The change is simply too slow for human senses to notice. Every star in the sky is moving, not drifting gently, but traveling at enormous speeds, tens, sometimes hundreds of kilometers per second, carried along by the rotation of the galaxy, influenced by gravitational interactions, following trajectories that unfold over millions of years. Ursa Major is no exception. The Great Bear feels permanent because its motion is subtle on human timescales. A lifetime is too short to reveal the shift. Even centuries pass without obvious distortion, but stretch time far enough and the illusion collapses. The constellation is coming apart. To understand this, we need to abandon the idea of the sky as a static backdrop and begin thinking of it as a dynamic system, one in which everything moves, nothing stays where it began, and patterns are temporary alignments rather than fixed structures. Astronomers describe the motion of stars across the sky using a concept called proper motion. It refers to the apparent movement of a star relative to distant background objects. Proper motion is incredibly small, measured in fractions of arcseconds per year, but over thousands of years it accumulates. Ursa Major is one of the most striking examples of this effect. Several of its brightest stars share a common direction of motion. They are traveling together like remnants of a long-dispersed group. This shared motion is invisible to the naked eye, but unmistakable when measured precisely. Over time, this movement reshapes the constellation. If we could speed up the sky, compressing tens of thousands of years into minutes, the Big Dipper would begin to stretch and warp. The handle would bend, the bowl would loosen. Eventually, the familiar ladle shape would dissolve completely. The bear would disappear. This is not speculation. Astronomers have reconstructed the past and future positions of these stars using precise measurements. They can show what Ursa Major looked like tens of thousands of years ago, and what it will look like tens of thousands of years from now. In the distant past, the Big Dipper was still recognizable, but subtly different. Its stars were closer together. The shape was tighter, more compact. In the distant future, the stars will spread apart, scattering across the sky. The pattern we know exists in a narrow window of time. This realization carries a quiet weight. Human history, from the first cave paintings to modern space telescopes, fits entirely within a brief moment when Ursa Major looks the way it does now. Every story told about the Great Bear, every myth, every navigational lesson, every scientific catalog was built on this temporary arrangement. The sky shaped culture, but the sky itself was changing all along. This introduces a profound shift in perspective. We often think of time as something that happens to us, a river we float down, measuring change in our own lives. Astronomy forces us to reverse that perspective. We are the brief phenomenon. The sky is the long one. Patterns that feel permanent are, in cosmic terms, fleeting. Ursa Major reminds us of this gently. Unlike dramatic events, supernovae, eclipses, comets, its change is slow and patient. It does not announce itself, it simply unfolds. This slowness is why ancient observers perceived the sky as eternal. For them, it effectively was. A pattern that remains unchanged for hundreds of generations feels fixed beyond question. But science gives us longer eyes. With instruments and records, we can extend perception beyond a single lifetime. We can see motion where none was visible before. We can reconstruct the dance behind the stillness. And when we do, the sky becomes something new, not less beautiful, but more alive. The stars of Ursa Major are not arranged for our benefit. They are not holding a pose. They are travelers passing through a region of space that happens, for now, to align with our line of sight. This alignment will not last. Eventually, future observers, if they exist, will look up and see a northern sky without a dipper. They may create new patterns from different stars. They may tell new stories. They may have no memory of the Great Bear at all. And that is not a loss. It is the natural consequence of motion. Understanding this challenges one of our deepest intuitions, that the sky is the most stable thing there is. In reality, it is the slowest changing thing we can see directly, which is not the same as being unchanging. This difference matters, because when we treat the sky as fixed, we treat our interpretations of it as final. We assume the patterns we see are somehow inherent, meaningful in themselves. Recognizing motion breaks that assumption. It reveals that meaning is contextual. Ursa Major mattered because it was stable enough for humans to build stories, tools, and knowledge around it. It did not need to be eternal. It only needed to outlast human memory. This reframes how we think about permanence. The universe does not offer permanence. It offers timescales. Some are short, some are long. Human culture occupies a middle ground, long enough to preserve tradition, short enough to be overwhelmed by cosmic change. Ursa Major sits at that intersection. It is stable on the scale of civilization, unstable on the scale of the galaxy. This duality gives it its power. The motion of Ursa Major also reveals something about the stars themselves. Their shared direction of travel hints at a common origin, a time when some of them were born together from the same cloud of gas and dust. Over millions of years, gravitational interactions stretched that family apart. What we see now is a snapshot of dispersal. The constellation is not a group, it is a memory of a group. This memory is encoded in motion rather than shape. The stars no longer sit close together, but their trajectories still carry traces of shared history. Astronomy, in this sense, becomes archaeology. We read movement the way archaeologists read layers of soil. Each trajectory is a clue. Each proper motion measurement reveals a story that spans millions of years. Ursa Major's story is one of gradual separation. And yet, that separation has been gentle enough to preserve the illusion of unity for us. There is something quietly poetic about this. The Great Bear, symbol of endurance, turns out to be a pattern in slow decay. The constellation that guided travelers and anchored myths is itself transient, held together only by chance alignment and cosmic timing. This does not diminish its significance, it deepens it. Because it reminds us that what matters does not need to last forever. It needs only to last long enough to shape lives, cultures, and understanding. Ursa Major did that. The knowledge that it will one day fade does not erase its past. It adds urgency to the present. We are living in the era when this pattern exists, when it is visible, meaningful, and woven into human awareness. Future skis will be different. Past skis were different too. And this brings us to an important realization. Ancient humans did not see exactly the same Ursa Major we see today. The differences were small, but they existed. Over tens of thousands of years, the constellation has already shifted. The bear our ancestors saw was slightly more compact. The dipper they used to navigate was subtly tighter. These changes were too slow to notice, but they were real. This means the stories themselves were built on a moving target. Myth adapted without knowing it. The sky did not need to be fixed for meaning to persist. Meaning flowed with change, carried forward by memory rather than precision. Science now allows us to see this process from the outside. We can watch the sky dissolve into motion. We can anticipate future distortions. We can understand that the constellations are snapshots in a long film. And in doing so, we gain a new kind of humility. The sky is not a monument. It is a process. Ursa Major teaches this lesson quietly. It does not demand attention. It simply waits, changing at a pace that outlasts our impatience. The Ursa Major moving group. If the sky appears still, it is only because its motion unfolds on timescales far longer than a human life. And if the stars of Ursa Major appear unrelated, scattered across depth and distance, it is only because their shared history is written not in position, but in motion. For centuries, Ursa Major was understood as a visual pattern and a cultural symbol. Its stars were catalogued, named, and mapped, but there was no reason to suspect a deeper connection among them. They looked aligned by chance, and chance seemed explanation enough. That changed when astronomers began to measure the sky with unprecedented precision. As instruments improved and observations accumulated, subtle shifts in stellar positions became detectable. These shifts were tiny, fractions of a degree spread across decades, but they were consistent. Some stars were not moving randomly, they were moving together. This was the first hint of what would later be called the Ursa Major moving group. A moving group is not a cluster in the traditional sense. It is not a tight knot of stars bound by gravity. Instead, it is a loose association, a collection of stars that share a common direction of travel through space. They are companions not because they remain close, but because they remember where they came from. The idea is simple but profound. Stars are born in groups. They form within vast clouds of gas and dust, collapsing under gravity, igniting nuclear fusion, and emerging together into the galaxy. At birth, they are close, packed within regions far smaller than the distances that separate stars today. But the galaxy is not gentle. Gravitational tides stretch these newborn families apart. Encounters with other stars, clouds, and spiral arms slowly scatter siblings across space. Over millions of years, the cluster dissolves. The stars drift away from one another, becoming indistinguishable from the general stellar population. Position is lost. Motion remains. This is what astronomers discovered in Ursa Major. Several of its brightest stars, stars that appear unrelated when viewed in isolation, share nearly the same velocity vector. They are moving through the galaxy together, like leaves carried by the same current, even though they no longer float side by side. This shared motion is the fingerprint of a common origin. Long ago, perhaps hundreds of millions of years in the past, these stars were born from the same stellar nursery. They ignited around the same time. They began their journey together, and although they have since spread out across tens of light years, their paths through the galaxy remain aligned. The Ursa Major moving group is the ghost of a star cluster. This realization changes how we think about the constellation. Ursa Major is not a physical object, but part of it carries physical memory. The familiar pattern we see in the sky is not entirely coincidental. It is partially rooted in shared history, encoded not in shape, but in direction. This is easy to misunderstand. The moving group does not explain the Big Dipper's shape. Perspective still plays the dominant role, but it explains why several of its stars behave similarly, why they drift together through the galaxy instead of dispersing randomly. It reveals a layer beneath appearance. Astronomy often works this way. Surface patterns invite deeper investigation. When measured carefully, those patterns sometimes reveal structure hidden in dimensions we cannot see directly. In this case, the hidden dimension is time. The stars of the Ursa Major moving group are ancient. They formed long before humans existed. Their birth cloud has long since dissipated. Their original cluster no longer exists. What remains is motion, a shared trajectory through a rotating galaxy. To trace this motion, astronomers combine several kinds of measurement. Proper motion tracks how stars move across the sky. Radial velocity measures how fast they move toward or away from us. Distance tells us how far they are in three-dimensional space. When these pieces are assembled, a remarkable picture emerges. Some stars in Ursa Major are not just moving in the same direction, they are moving at nearly the same speed. This is unlikely to happen by chance. It is the signature of shared origin. Not all the stars in the constellation belong to this group. Some are unrelated interlopers passing through the same line of sight. This mixture reinforces an important lesson: constellations blend real structure with illusion. The Big Dipper is not a cluster, but it contains echoes of one. This hybrid nature makes Ursa Major especially valuable to astronomy. It offers a case study in how stars evolve from tightly bound groups into dispersed populations. It shows how galactic dynamics stretch and scatter stellar families over time. In a sense, the Ursa Major moving group is a lesson in agging. At birth, stars are close and identifiable as a group. In middle age, they drift apart but remain recognizably related through motion. In old age, even that connection fades and they become indistinguishable from the background. Ursa Major sits in the middle of this process. The group is old enough that its original cluster is gone, but young enough that motion still reveals kinship. This makes it a snapshot of a transitional stage in stellar life. There is something quietly resonant about this. Human families disperse too. Generations move apart, settle in different places, lose daily contact. Over time, only records and shared direction preserve the connection. In the sky, the same process unfolds on scales beyond imagination. The moving group also challenges a common misconception that stars are isolated objects, born alone and drifting independently. In reality, most stars are born in groups. Solitude is the result of time, not origin. This perspective reframes the night sky. What appears as scattered points of light is actually the aftermath of countless collective beginnings. Each star carries a history of association, separation, and motion. The galaxy is not a static arrangement, it is a river of stellar trajectories. Ursa Major's moving group gives us a rare chance to see this river flowing. It also reminds us that constellations are not purely arbitrary. While their shapes are defined by perspective, their membership sometimes overlaps with deeper structure. The sky is not entirely random. Patterns emerge because history leaves traces. Understanding this adds nuance to everything we have discussed so far. The Great Bear is not just myth layered onto coincidence. It is myth layered onto partial truth, onto a pattern that happens to preserve both visual clarity and physical memory. This does not mean ancient observers sensed the moving group. They did not measure velocities or reconstruct origins, but their intuition that these stars belong together in some way was not entirely misguided. They felt unity where science later discovered relationship. This is a recurring theme in astronomy. Human perception often detects coherence before it can explain it. Stories form around patterns that later turn out to have deeper roots. Myth is not science, but it is not random either. It arises from sustained attention to stable features of the world. Ursa Major invited that attention. The discovery of the moving group also illustrates how astronomy builds understanding incrementally. No single observation revealed it. It emerged from decades of careful measurement, comparison, and refinement. This slow accumulation mirrors the slow motion it studies. Patience reveals structure. Today, the Ursa Major moving group is used as a benchmark in stellar astronomy. It helps calibrate models of stellar evolution. It provides insight into how stars disperse. It serves as a reminder that motion, not position, is often the key to understanding cosmic history. But for all its scientific importance, the moving group remains invisible to the naked eye. When you look up tonight, You will not see trajectories or velocities. You will see the same familiar dipper hanging quietly in the northern sky. And that is appropriate. The sky does not demand that we see everything at once. It allows layers of understanding to unfold over time. First pattern, then story, then function, then motion, then history. Ursa Major has guided humanity through all of these stages. It began as a shape remembered in darkness. It became a story told by firelight. It became a compass for travelers. It became a subject of measurement. And now it reveals a shared journey through the galaxy itself. This layered meaning is what makes the constellation enduring, not permanence, but depth. Time, memory, and the changing sky. There is a quiet mismatch between the time the universe keeps and the time we are built to understand. Human lives unfold quickly, years feel long, decades feel significant, a century sounds vast, but the sky does not recognize these scales. Stars do not mark birthdays, constellations do not notice generations. What feels permanent to us is often only momentary to the cosmos. Ursa Major lives inside this mismatch. To human eyes, it is stable, reliable, the same pattern our grandparents saw and their grandparents before them. The Great Bear feels like a fixture of reality, something that has always been there and always will be. But this feeling is an artifact of memory. The sky changes slowly enough that it outpaces our ability to notice. Its motion is spread across timescales too long to register intuitively. Our brains evolved to detect change that matters for survival, movement of animals, shifts in weather, cycles of day and night. Changes that unfold over tens of thousands of years fall outside our perceptual range. As a result, we mistake slowness for stillness. This mistake shaped how ancient people understood the cosmos. When generations pass without visible alteration in the stars, the sky appears eternal. It becomes a backdrop against which all other change occurs. Life moves, seasons turn, civilizations rise and fall, the stars remain. Or so it seems. Ursa Major played a central role in reinforcing this illusion. Because it never sets for much of the northern hemisphere, it feels anchored. It circles the pole endlessly, returning to familiar positions night after night. Its motion is repetitive, predictable, and comforting. This repetition creates memory. People remember the sky not as a precise map, but as a feeling, the feeling that certain stars are always there, the feeling that north is stable, the feeling that something exists beyond the chaos of human affairs. These feelings matter. They shaped early cosmologies, religious ideas, and philosophical thought. If the sky does not change, then it must be fundamentally different from the Earth. If it is different, then perhaps it is perfect, divine, or eternal. For centuries, this belief went unchallenged, not because it was correct, but because it was consistent with experience. Even when early astronomers began to measure the heavens more carefully, the changes they detected were subtle. Planets wandered, comets appeared and vanished. Eclipses interrupted the regular rhythm, but the stars themselves remained fixed relative to one another. Ursa Major looked the same. This reinforced the idea that constellations were permanent structures. The sky became a kind of cosmic archive, unchanging, reliable, immune to decay. It took extraordinary patience and technological advancement to break this illusion. Only when astronomers began comparing star positions across centuries did motion become undeniable. Tiny shifts, once dismissed as error, accumulated into patterns. Proper motion revealed that stars were not fixed points, but travelers. The sky was alive. But even with this knowledge, the human experience of the sky did not change overnight. Understanding motion intellectually is not the same as perceiving it emotionally. The Great Bear still looks the same when you step outside at night. This gap between knowledge and experience is important. We live surrounded by processes we cannot feel directly. The Earth rotates beneath our feet at incredible speed. It orbits the Sun at tens of kilometers per second. The solar system moves through the galaxy. The galaxy itself drifts through a larger cosmic structure. None of this motion is perceptible without instruments. Ursa Major becomes a lesson in humility here. It teaches us that perception is not truth, it is approximation. What we experience is filtered through biological limits and timescales tuned to survival, not to cosmic accuracy. The sky appears still because stillness is useful. A reliable sky allows navigation. A predictable pattern allows memory. If the stars changed quickly, they would be useless as guides. Their slowness is not accidental, it is a consequence of distance and scale. Distance stretches time. The farther away an object is, the slower its motion appears. Stars are so distant that even their enormous velocities translate into minute changes from our perspective. This is why constellations persist long enough to become cultural fixtures. Ursa Major benefited from this persistence. It existed long enough for humans to build stories, tools, calendars, and identities around it. It did not need to be eternal. It only needed to outlast human memory. And it did. But memory itself has limits. Human cultures forget, stories fragment, meanings shift. The sky appears to anchor memory, but it does not preserve it perfectly. Each generation reinterprets what it sees. Each culture overlays new significance onto old patterns. Ursa Major has been many things across time: a bear, a chase, a ladle, a plow, a wagon, a bureaucratic instrument of heaven, a compass, a teaching tool. None of these interpretations erased the others. They accumulated. This accumulation creates a layered sky, a palimpsest of meaning written and rewritten over thousands of years. When you look at the Big Dipper, you are not seeing a single story. You are seeing the residue of many. This is why the constellation feels familiar even if you do not know its history. Familiarity is inherited. It is cultural memory encoded in education, art, language, and tradition. But cultural memory is fragile. In the modern world, fewer people look up. Light pollution obscures stars. Screens draw attention inward. Navigation no longer requires celestial knowledge. The sky recedes from daily life. Ursa Major remains visible, but its role is changing. For many, it is now an image encountered in books or apps rather than a lived reference. Its function as a compass has become symbolic. Its mythological stories are no longer widely known. Its scientific significance is confined to classrooms and observatories. And yet it persists. This persistence raises a question. What happens to a constellation when its practical and cultural roles fade? The answer is not disappearance, but transformation. Ursa Major is becoming something else. It is becoming an object of reflection rather than utility, a reminder rather than a guide, a symbol of connection to a time when the sky mattered more directly to human survival. In this way, the constellation mirrors broader changes in human time perception. Modern life accelerates experience. Information moves quickly. Change feels constant. In such a world, the slow sky offers contrast. It becomes a counterweight to speed, a reminder of processes that unfold beyond urgency. Looking at Ursa Major invites patience. It asks us to imagine time beyond our own, to consider that the stars we see tonight were already ancient when humans first noticed them, to accept that they will continue moving long after our stories fade. This acceptance can be unsettling. Humans are meaning-making creatures. We want permanence. We want significance to endure. Learning that constellations dissolve over time can feel like loss. But it can also feel liberating. If meaning arises from relationship rather than permanence, then it does not require eternity to matter. Ursa Major mattered because it was present when humans needed it. It shaped navigation, myth, and understanding during a critical phase of human development. That is enough. The sky does not owe us permanence, it offers participation. By recognizing the changing nature of Ursa Major, we align our understanding with reality rather than illusion. We learn to appreciate patterns not as fixed truths, but as moments of alignment between perception and cosmos. This perspective changes how we relate to the universe. We stop asking what is permanent. We start asking what is meaningful now. Ursa Major teaches this gently. It does not announce its impermanence. It simply continues moving, indifferent to whether we notice. Its lesson is not one of urgency, but of scale. Human time is narrow. Cosmic time is vast. Between them lies a space where meaning is created. The Great Bear occupies that space. Ursa Major in early science and astronomy. Long before astronomy became a science of equations and instruments, it was a discipline of memory. Observers watched the sky night after night, year after year, noting what returned, what shifted, and what never seemed to change. They did not begin with theories. They began with patterns, and among those patterns, Ursa Major held a privileged place. When early astronomers set out to make sense of the heavens, they needed anchors, reliable reference points that could orient observation and comparison. The Great Bear offered exactly that. Its visibility, consistency, and prominence made it an ideal starting place for systematic study. This is how myth quietly became method. In the ancient world, the boundary between astronomy and astrology was porous. The same observers who measured star positions also interpreted their meanings, but measurement mattered, precision mattered, and slowly, across centuries, a new way of relating to the sky emerged, one that emphasized consistency over story. Ursa Major was central to this transition. Early star catalogues did not begin by mapping the entire sky uniformly. They grew outward from familiar regions. The northern sky, dominated by circumpolar constellations that never set, was particularly attractive to observers. These stars could be tracked year-round, providing a stable frame of reference. Ursa Major, circling endlessly around the pole, became a natural backbone for celestial mapping. One of the most influential early works to formalize this mapping was the star catalogue preserved in the Almagest, compiled by Ptolemy in the 2nd century. This work did not invent the constellations it described. It organized them. It fixed their positions relative to one another and to the celestial sphere. Ursa Major appears prominently in this system. Ptolemy listed its stars, described their relative brightness, and placed them within a coordinate framework that allowed future astronomers to compare observations across time. For the first time, the Great Bear was no longer just a story or a guide, it was data. This shift did not erase myth, it recontextualized it. The names remained, the shapes remained, but their role changed. They became labels for reference points rather than explanations for motion. The sky was no longer animated by gods, it was governed by geometry. Yet geometry needed landmarks. In a world without telescopes, naked-eye astronomy depended on recognizable patterns. Ursa Major's stars were bright enough to be measured reliably. Their arrangement was distinctive enough to be identified without ambiguity. This made them ideal calibration points. Early astronomers used these stars to test models of the cosmos. Was the Earth stationary or moving? Did the heavens rotate around us, or did something deeper govern their motion? To answer these questions, observers needed stable stars, objects that could be assumed fixed while hypotheses were tested. Ursa Major provided that apparent fixity. Ironically, the very constellation we now know to be slowly changing was treated as immovable. This assumption was reasonable. On human timescales, the stars were fixed. Their positions did not shift perceptibly over generations. The difference between appearance and reality was too subtle to matter at the time. And so Ursa Major became part of the scaffolding on which early cosmology was built. As astronomy spread through the Islamic world during the medieval period, Greek texts were preserved, translated, and expanded. Scholars refined measurements, corrected errors, and added new observations. The Great Bear remained central. Its stars were used to check the accuracy of instruments. Its motion around the pole was used to study Earth's rotation. Its consistent visibility made it a testing ground for improved observational techniques. This continuity across cultures is striking. Greek astronomers, Islamic scholars, and later European observers all relied on the same stars to ground their work. Knowledge passed not just through texts, but through the sky itself. When the Renaissance revived interest in precise measurement, Ursa Major was already embedded in astronomical practice. Star charts grew more detailed, coordinates more refined, but the basic framework remained intact. The constellation was familiar, trusted, reliable. Even as revolutionary ideas emerged, challenging Earth's place in the cosmos, the stars of Ursa Major continued to serve as reference points. They did not resist change, they enabled it. This is an important distinction. Scientific revolutions do not discard all prior knowledge, they rearrange it. Old tools find new purposes, familiar landmarks become part of new maps. Ursa Major exemplifies this process. When astronomers began to consider the possibility that the Earth moves, they needed evidence. Parallax, the apparent shift of stars due to Earth's motion, became a key test. Observers looked to bright, well-known stars to detect tiny changes. Ursa Major's stars were among those examined. At first, no parallax was detected. This absence was taken as evidence that Earth did not move or that the stars were unimaginably distant. Eventually, the latter proved true. The failure to detect parallax was not a failure of observation, it was a revelation of scale. The universe was far larger than anyone had imagined. Ursa Major had helped reveal that truth, not by changing, but by staying apparently the same. As telescopes improved, stars once thought singular revealed companions. Bright points split into systems. Subtle color differences became apparent. The Great Bear, once a simple outline, became a field of complex stellar phenomena. But the constellation itself remained a framework. Astronomy advanced by adding layers of understanding without dismantling the scaffolding that supported observation. Ursa Major's role as a guide, a reference, and a teaching tool persisted. Even today, introductory astronomy courses often begin with the Big Dipper. Students learn to find north. They learn to identify other constellations from it. They learn to navigate the sky using the same pattern their ancestors used. This continuity matters. It reminds us that science is not detached from human experience. It grows out of it. The sky we study is the same sky our ancestors watched, interpreted differently, measured more precisely, but never replaced. Ursa Major's journey from myth to science was not a rupture, it was a translation. Meaning shifted from narrative to measurement. Function shifted from survival to understanding. But the stars themselves remained constant enough to support both. This is why the constellation occupies such a prominent place in the history of astronomy. It is not because it is physically special. It is because it is perceptually and culturally ideal. It is easy to find. It is hard to forget. It behaves predictably. These qualities made it indispensable in the slow construction of scientific knowledge. As astronomy continues to evolve, probing exoplanets, galaxies, and cosmic origins, the Great Bear no longer sits at the cutting edge, but it remains at the foundation. Foundations are not glamorous, they are rarely noticed, but without them nothing stands. Ursa Major is one such foundation. Looking up with new eyes. At some point, explanations fall away. After the distances, the motions, the myths, the measurements, and the models, there comes a moment when the mind grows quiet again. The sky does not demand understanding, it waits. And so we return to the beginning, not to relearn, but to see. On a clear night, when the world finally softens its noise, the Big Dipper still rises. 7 familiar stars appear one by one, arranging themselves into a shape that feels almost personal. You recognize it instantly, not because you memorized it, but because it has been part of your mental landscape for as long as you can remember. Only now, something is different. You no longer see a simple object. You see layers. You see light that has traveled decades through space to reach you. You see stars moving silently, drifting apart even as they appear united. You see an ancient pattern that existed before writing and will dissolve long after modern cities fade. You see a meeting between human perception and cosmic reality. This does not make the Big Dipper feel distant, it makes it feel intimate. Because intimacy is not about closeness in space, it is about familiarity through time. Ursa Major has accompanied humanity quietly. It did not announce itself as important. It did not demand belief. It simply remained visible long enough for humans to notice, remember, and return to it. Generation after generation stood beneath the same slow rotation and felt something similar. Orientation, reassurance, curiosity, humility. They did not need to understand why it moved. They only needed to know that it did. Even now, in a world shaped by screens and satellites, the constellation retains that power. It does not compete for attention. It waits patiently until someone looks up. And when they do, the old response returns. Not awe in the dramatic sense, but recognition. Recognition that we are standing on a moving planet beneath a moving sky. Recognition that what feels permanent is only stable for a time. Recognition that meaning arises not because the universe assigns it, but because we are capable of finding it. The Big Dipper teaches us to hold complexity without losing simplicity. It shows us that something can be an illusion and still matter, that a pattern can be temporary and still shape history, that understanding more does not require feeling less. Knowing that the constellation is not physically real, does not erase its reality in human experience. It clarifies it. Ursa Major exists in the space between objectivity and imagination, a place where science and story do not compete, but inform one another. This space is important. It is where humans have always lived. We do not experience the universe directly. We experience it through perception, memory, language, and culture. The night sky becomes meaningful because we engage with it, not because it offers meaning freely. In this sense, looking up is an act of participation. When you recognize the Big Dipper, you are joining a lineage of attention that stretches back tens of thousands of years. You are sharing a moment with people who had no names for galaxies, no equations for motion, no understanding of light years, but who still found orientation beneath the same stars. The knowledge you now carry does not separate you from them, it connects you. They knew the sky by familiarity. You know it by explanation. Both are valid ways of knowing. And both end in the same place, a quiet awareness of scale. Ursa Major does not place us at the center of the universe. It gently removes us from that illusion. It reminds us that we are observers within something vast, brief participants in a story that began long before us and will continue long after. This realization can feel small, but it can also feel grounding. There is comfort in knowing that not everything depends on us, that the universe does not require our attention to exist, that the stars shine whether or not they are named. And yet, there is also something meaningful in the fact that we noticed them at all. The Big Dipper did not need us to exist, but its meaning did. That meaning, built from memory, survival, curiosity, and shared attention, is one of humanity's quiet achievements, not written in stone, not stored in books, but carried forward by looking up and pointing. Do you see that? Yes, I see it. That exchange, repeated across millennia, is the true legacy of Ursa Major. Not the bear, not the dipper, but the act of noticing together. So when you next find yourself beneath a dark sky, pause. Let your eyes adjust. Let the stars emerge. Find the familiar shape, not to analyze it, not to measure it, but simply to acknowledge it. It is still there. And for this moment in cosmic time, so are you.